Howdy, my name is Chase Mullins, and I am in the summer of 2024 Oceanography class, The Blue Planet and Our Oceans. Tectonic plates and Earth's movements. The Earth's continents and islands are all not set in place. So the way that we grow up and we see the maps and we see the world and we see where all the land masses are, that's not where they've always been. Come to find out, all these land masses are associated to things known as tectonic plates, or just the thing that the land masses sit on top of the Earth. And I say on top because come to find out, there are several layers throughout the Earth, and that these tectonic plates don't travel from the top of the Earth to the center of the Earth. They actually have a couple different layers all the way through the lithosphere. These layers are going to be dictated by their density. The closer to the core, the more dense the layer is going to be. What's crazy though is that once we get to the asthenosphere, the heat from the core and the pressure from the rest of the Earth is just at this perfect sweet spot to prevent it from being a solid or really a liquid. So we get a kind of in-between state, and it's kind of not really anything we like to say is solid or liquid. So we call it plastic. Not so much plastic in the way that you would think, like a water bottle or Save the Sea Turtles, but plastic in nature in that it kind of flows. But with it flowing, that means everything above it is going to move as well. I like to think of it in the analogy of Sonic ice. If you were to get a whole bunch of Sonic ice and put it in a cup, fill that cup up with water. The top of the ice, if you were to look down into the cup, would be like our islands, our continents, and the things that we can see. All the ice below that would represent the different layers of the Earth going through. Once you get to the pure water, that pure water would represent the asthenosphere. If you were to spin the bottom of that cup, spin the water at the bottom of that cup, it would cause the ice above it to rotate, and so on and so forth, till it got to the top, to the point where the things that you can see as your continents and islands will start to spin as well. So in the same way that this ice rotates and moves across the cup, so do our continents, our islands, our plates. All of these things move across our Earth. So our maps always have to be redrawn, and throughout history, the maps have looked very different. Now, when things move like this and there's not an infinite amount of space for them to go, we're going to have collisions. So when one plate hits another plate, goes away from a plate, there's a lot of different ways that it can go. But again, we're trying to keep this between 2 and 5 minutes. So we're going to go over 2. First one being convergence. Convergence is not the most favored one, it's not the one that we love, but it's when 2 plates of landmass collide towards each other. Now, there's different variances of this, but the main one I want to go over is when 2 plates of like density come to collision. When 2 plates of like density come to collision, neither one is going to want to yield to the other, but that landmass has to go somewhere. If it's not going to go down and subduct, it has to go up. So all that land material that's colliding against one another, that's just arguing against each other, is just going to start to rise upward. This gives us our mountains, our ridgeways, our undersea mountains, all the different kinds of ways for Earth to come upward. Now, what's the other way, or the opposite of that? That would be subduction. Subduction is when coastal and continental plates collide with one another. The one with the heavier density is going to slide underneath or subduct from the other one. More simply put, the one that is denser slides under the one that's lighter. Lighter goes on top, heavy goes inside. What makes this interesting is that when this layer of the coastal plain, or the coastal plate rather, subducts underneath the continental plate, it actually gets recycled down into the lithosphere, asthenosphere, all that other kind of good spheres, and recycled back into Earth's rotation, magnetic field, and can come up. Also, due to the fact that the oceanic plate is more dense than the continental plate, the oceanic plate will subduct underneath the continental plate. This is why we don't have ancient ocean beds. This is why there isn't some place that has all the bones, whale carcasses, and pirate treasure. All of the oceanic plates end up subducting in, rotating out, recycled, and we get new. So no ancient plates for us. So these are two primary ways that whenever two plates collide, these are one of the two primary ways that the reaction will go. At this time, I'd like to open it up to questions. If you have any, please feel free to email me at chase.mullins@tamu.edu. I will get back to you as soon as possible. If not, I would like to conclude at this point. Gig 'em.